This video walks through Packet Tracer Assignment 5.1.3.6, Configuring Router-on-a-stick Inter-VLAN Routing. This is Chapter 5 in the Routing and Switching Essentials curriculum of the Cisco Networking Academy. So in this lab, we are presented with a topology. As you can see here, we've got PC1 that is in VLAN 10. The left side of the switch, everything is in 172.17.10.0, that network. The right side of this switch here is PC3. We've got VLAN 30 connected, or PC3, which is running on VLAN 30, and everything to the right of that switch is in 172.17.30.0 network. Okay, so we've got a router up there. You can see the red link light, so that means it's not operational right now. Based off of end-to-end connectivity, if we wanted to ping PC1 to PC3, we know that they're in different VLANs. So up until this point in Chapter 4, we were not able to talk across different VLANs. We did do some VLAN configurations, setting our end devices to be in access mode accordingly. So for instance, the left side of S1 there, we know that FA011 should be in access mode for VLAN 10. The right side, we know that FA06 there that PC3 is connected to should be in access mode carrying VLAN 30. Now, we're involving a router so that we can talk between our VLANs. So that's why it's called inter-VLAN routing. So we're going to go to simulation mode really quickly just for me to show you something. This does not affect the grading of this lab. But if we try to ping from PC1 to PC3, okay, and we click on the capture forward, it just shows us where an outline of what should happen as far as us sending the packet. If we click it again, it shows us again it should go from S1 to PC3, but we'll notice we get a red light here, or a red X here, saying the packet never leaves PC1 in actuality. Why is that? Well, if we know that it is not leaving PC1 at all, that means it's actually like facing a roadblock on this line right here. Okay, so where my mouse is, this line right here, traveling from PC1 to S1, is saying, hey, you cannot travel down this path. Well, the reason for that could be because FA011 does not have the correct VLAN configured, which would carry VLAN 10. Same thing would happen if I send it from PC3 to PC1. All right, if we get a roadblock here that's telling us we can't even get on that line, then that means we don't have FA06 carrying VLAN 30. So let's go back to real-time mode, okay? And it tells us in our directions that that is the case. In part 2, it actually has you add the VLANs to the switch. So if we don't have any VLANs at all even created, then we know that the port itself is definitely not configured correctly, okay? So we're going to go to Enable, Config T, and we're going to add the VLAN. So remember, our command is VLAN, and then whatever number you want it to be. Okay, it allows you to name it. I don't think they have us name it anything, so we're good there. We can just exit back out, and then VLAN 30. Okay, so we got our two VLANs created. Remember, you can do a show VLAN brief. Oh, sorry, do show VLAN brief. And you see here that we've got our two VLANs created. Now we have not added any port assignments to it, so let's do that. Okay, so we want to go into the specific interface, which again, FA011 here you can see is what is connected to PC1. And we want to do switch port mode access. Now remember, trunking mode is only for switch to switch or switch to router configuration, and we're going to see that in a minute, where all multiple VLANs need to be carried. With switch port mode access, the access mode is only going to carry one VLAN. So switch port mode access, and then switch port access VLAN 10, because that's the one we want to carry. Okay. We're going to also go into interface FA06 because again on the right side that is what's connected to PC3, and we're going to do switch port mode access again, but this time we'll do switch port access VLAN 30. Okay, so you can see our lights turn orange for a moment. That's because it's renegotiating everything. So it's, telling it, hey, you only need to cover 10 traffic to the left. Hey, you only need to carry 30 traffic to the right there. So I'm gonna hit the fast forward time button just so it'll jump ahead for us. Okay, now if I do a show VLAN brief, and again, we have to type do because I didn't back all the way out to where we just have a pound symbol. Okay, we see that we've got FA011 carrying VLAN 10. We got FA06 carrying VLAN 30. Okay. Now, it says test connectivity between PC1 and PC3. From PC1, ping PC3. The ping should still fail. Why are the pings unsuccessful? Well, that's because this line over here is technically only carrying VLAN 30 traffic. Okay, so it doesn't really know how to get out of its own VLAN yet. To do that, we would have to actually involve a router, and this is where our legacy routing came back in, Inter-VLAN routing, where we would have to physically, and it's on our notes page in Moodle, okay, we would have to physically go in here, as you see here in this example, and connect a separate line for every single route that we needed for every VLAN. That is very costly. Okay, so to avoid that, we did a router on a stick configuration here, but we do have to involve some 802.1 encapsulation. So on the router and the switch, we're going to have to do some configurations here. So on the router, we'll do those first. Okay, so when we get in configuration mode here, we're going to create the sub interface, and we need a sub interface for every VLAN. So usually, like for VLAN 10, they'll do the port number and then .10. So here they do G0.10. That's going to carry VLAN 10. Just to make it not confusing, we just go with the same numbers there. Okay. So now we're going to set it with an actual IP address. This is almost like the default gateway, kind of like we did way back. So here we're going to do IP add 172.17.10.1, 255.255.255.0. Oh, sorry. We've got to make it encapsulation first. So sorry, we got to do encapsulation .1Q and then whatever VLAN you want to carry. And again, you'll get that message. So it's actually good that I did that. You'll get that message. That means you need to enable encapsulation for carrying that VLAN. So encapsulation .1Q and then whatever VLAN number you want to carry. So now we can go back and add the IP address. Okay, so again, you notice that IP address still falls in this range. So our range of 172.17.10.0 to 172.17.10.255, PC1 and that IP address should fall in that range. Again, this is kind of like setting the default gateway, but the router is kind of serving as like the default gateway for two different subnets almost. That's kind of like the best example I can think of for that. So we've got it set for that one, but we also need to set it for PC3's VLAN 30. So we need to do interface G0/0 because it's the same physical port that it's going to run through 0/0.30. Okay, and again, we just try to keep it simple. Encapsulation .1Q30 because it's carrying VLAN 30, and then IP add, it's in your chart up there. Okay. And also we need to type no shut because I don't know, well, they should have turned on. So usually they turn on 99% of the time. All right, now we've got the sub interfaces configured. Okay, we got one for VLAN 10, one for VLAN 30. Now the next thing we have to do is actually turn the physical port on because even though these are sub interfaces, they still get routed through that one physical port. So that was the only one drawback in our notes that we noted was that every single VLAN's traffic before it goes somewhere is going to go to router 1 and it's going to go to that specific port. So that port is carrying a lot of traffic. So it could get bottlenecked, but hopefully our router is fast enough to handle it. So we have to actually go into interface G00, okay, which is the physical port, okay, not the sub interface, but the actual physical port, and type in no shut. We do not need any actual IP addressing on that port because it will actually refer to the sub interfaces for that. Now, the last thing we have to do is on switch 1, we need to make the port that it shares, like the way it's going out to R1, which is G01, we need to make sure that that is in trunking mode. Okay, because again, switch to switch needs to be in trunk mode because it's going to carry a lot of VLAN traffic, several VLANs, not just one like access mode does. So even though this light is green here, you actually still will not have connectivity. Okay, remember, green lights do not necessarily denote a fully functional network. So here we're going to do interface G01 and we're going to go to switch port mode trunk. Okay, and you see it actually changed it to up. Okay, and then switch port trunk allowed VLAN, and you could allow the 10 and the 30 here. Okay, no space. Switch port trunk allow VLAN, whichever ones you're allowing. And if you had a native VLAN, you could also set that, but this particular lab does not, I don't believe. Okay, so now again, it tells you to do 1-1, but it really is G01 on the switch, so they had that incorrectly labeled. So make sure you just make a note of that. But when we do a show VLAN brief now, again, we still see this here, as well as our G01 is now in trunking mode. So if we do a show run, we see our access modes, we see our VLANs there, and down here we see it's in trunk mode. Okay, now everything should ping from end to end. First one get failed, but now we have a successful. So we can ping from PC to PC. So what happens is, if you want to kind of trace it, you can go back to simulation mode and go from here to here, capture fast forward. Okay, you see it being sent up to the router, then being sent back down to switch 1, and then being sent over. So that's kind of how it works. Okay, so it's sent from one PC to the next, or sorry, from one PC to the switch to the router back to the switch to PC3. So that's kind of how it goes each time, almost like in a upside down T. Okay, that's just for this particular diagram. So if we added more VLANs, we could here. That's the point of inter-VLAN routing. It doesn't matter how many VLANs you have. You can have a lot of sub interfaces, only one port carrying a lot of traffic. Okay, so that concludes this lab. We got a 60 out of 60, which is 100%, and you got full connectivity.